Hey guys, welcome back to another edition in geometry. It's Mr. Anderson here with you. Today we're doing a combination of section 4.4 and 4.5. We're talking about the different ways that we can prove that triangles are congruent. Okay, and that's all we're going to do. It's going to be a pretty short one today. All right, so first of all, our objectives. We're going to use the SSS, which is side, side, side postulate, to look for triangle congruence. We're going to use SAS, which is side, angle, side. ASA is angle, side, angle. And then finally, we're going to use the angle, angle, side postulate. So these are the different things that we're going to look at where we can tell if two triangles are congruent or not. Okay, so we're going to start with side, 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 which we might abbreviate with SSS here. Basically what this says is that if you have two triangles, and in each of these triangles you know that all three sides are congruent to each other. In this case, AB is congruent to ED, BC is congruent to EF, and AC is congruent to FD, then the two triangles have to be congruent because of the side, side, side congruence. Okay, that's all you're saying is, do they have all three sides that are exactly the same length? Then we know it has to be congruent because of side, side, side. Okay, second, the side, angle, side congruence. All right, it starts to get a little bit trickier here, but basically what's going to happen here is you have to have two sides. And the reason why we say this in the order that we do, side, angle, side, is if you notice the angle, when we say side, angle, side, the angle is in between the two sides, right? The angle is in between the two sides, which is the same thing that happens in the diagram here. So if you notice, AB, side AB and side ED are congruent. Side BC and side EF are congruent. Those two sides are congruent to each other. And look at the angle that's congruent. The angle that's congruent is the angle that's in between those two sides. Between side 1 and side 2 is E. The side in between side 1 and side 2 is angle B, and that is congruent to E. So when we say side, angle, side, really important that means it goes in that order. It goes, there's a side, and then the angle, and then the other side. Okay, so it has to be in that order. A lot of times people get kind of confused about that, but it's the angle that's in between the two sides. And what they call that is they call that the included angle. And so that just means that's the angle that's in between the two sides is all that means, okay? So that would be the side, angle, side congruence. Okay, next we're going to talk about the angle, side, angle congruence. Now if you notice here, again, look at the order. It says angle, and then side, and then angle. So in other words, look at the word side is in between the two angles. So that's a clue. So when we look at the triangles here, it's the same thing. That if you notice the two angles, here we've got angle B is congruent to angle E, and angle A is congruent to angle D, and the side that's congruent is in between the two angles. So here's this angle and this angle. The side that's in between there is congruent to the side that's in between those two angles. Okay, so angle, side, angle. And again, that's called the included side. So that just means the side that is in between those two angles. Okay? And then the fourth one that we have to look at today is angle, angle, side. Now again, notice what order it's in. It says angle, then side. So in this case, you have two angles, but the side is not in between there. The side is kind of next to it. It's got to be in this kind of the same order there. So if you look here, it goes angle, angle, side. So if you look, kind of think of going around the triangle basically in order. You're going what, from an angle to an angle and then a side. And if you think here on this other one over here, what happens? We went from angle 2 to angle 1, and then we hit a side. So here we went from angle 2 to angle 1, and then we hit a side. If it went the opposite way, then it wouldn't be angle, angle, side congruence. Like for example, if this mark up here on BC, let's say it was on AC instead, then you could go angle 1, angle 2, and then a side. But on this one, now you go, oh, what? Angle 2, angle 1, and a side. It doesn't match up. So the angles have to be, and the side has to be in the right order there, okay? All right, let's look at some examples. The whole thing will be about looking at all these examples here, and we'll see what we can do. All right, example 1, here's our two triangles, and it's marked, okay? So if you notice, this side here is marked as being congruent to this side. So they have that side in common. Here's a second side that's marked as being congruent, and it's the angle in between those two sides. And so you say, hey, that's one of our things there. Do you remember what one that is? What's the order? It goes side, angle, side. So that would be side, angle, side, or we could just say SAS. Okay, so those are congruent because of the side, angle, side postulate. Okay? Example 2. Little trickier, because if you look at this, you go, hey, look at, they only told us this side is congruent to this side, and this side is congruent to that side. I don't have anything else to go on. Well, you got to remember some of the things that we've kind of talked about before, or what might make sense here. One of those things is, since these two triangles are basically sharing a side, they're sharing this side right here, aren't they? Well, that third side has to be the same length. It's the same length for both triangles. So this, you could say, is congruent to itself. And so now what do you have? You have a side, and a side, 1, 2, and 3, a side, and a side, 1, 2, and 3. So this would be side, side, side congruence. Okay, so sometimes you got to look for some little things like that. Everything might not be given to you. Okay, now we've got another situation here. We've got two sides that are congruent. We've got two angles that are congruent. That's all I've got. I don't have anything else. Okay, is there anything else I can figure out here at all? Well, if you notice, remember when two straight lines cross each other, they make a pair of vertical angles, which vertical angles are congruent to each other, okay? So what that means is this angle right here is congruent to that angle. And actually, I'm going to make 2 marks there since we've already got 1 mark. And so now take a look at that and go, now can we do something with that? Well, we've got an angle, a side, and an angle. So it goes angle 1, side, angle 2. And here we got what? Angle 1, side, angle 2. That works. We have angle, side, angle congruence. Okay? Hopefully you're starting to get the feel for what to look for. We got a few more examples though. All right, now in this one, we've kind of got a similar thing there, right? If you notice, we've got vertical angles. So this is already marked with 2 marks, so this time I'm going to mark my vertical angles with just 1. What is that? Well, you know what? If you look at this, you got angle 1, angle 2, and then you got a 90-degree angle. Angle 1, angle 2, and a 90-degree. But if you notice, one of the 4 things that I went over was not angle, angle, angle. We didn't have one that said angle, 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 did we? We've got 3 angles here, but that doesn't necessarily mean those triangles are congruent. One of these triangles could actually be smaller than the other one and still have all the same angles. Because remember, every single triangle always has 180 degrees. So just because the angles are all match up does not necessarily mean they're congruent. So in this case, we would have to say this is not possible. So we cannot prove this beyond a shadow of a doubt based on what we have. We have to say that is not possible. All right, example 5. All right, how about this one? Well, what can we figure here? We've got an angle and an angle. But if you look closely, remember, here again, the triangles, they share a side. Oh, so look at this side would be congruent to itself. Does that give me something that I can use? Well, I've got angle 1, angle 2, and then a side. Angle 1, angle 2, and a side. So that would be angle, angle, side. And that is one of the ones that we talked about, angle, angle, side. So we have angle, angle, side congruence. Okay? All right, example number 6. What can we find here? Well, again, we've got vertical angles. So that means this has to be congruent to that, right? And now, look really carefully, because you could get fooled on this one. Look at on this lower triangle, we go angle 1, or side 1, sorry, side 1, angle, side 2. So that would be side, angle, side. But look at the other side real carefully. What we have there is, we have two sides and an angle, but look at where this angle is. That angle is not in between the two sides on that one. It's not included. It's not in between the two sides. What we really have here is side, side, angle. That's not the same as this, is it? So if you notice, we had two sides that are congruent, 1 and 2, and we had two angles that were congruent, but they're not in the right order. Okay, so this one's very tricky, but we would have to say, again, this is not possible because it's not one of those four instances that we talked about. Okay? What about this one? Well, you look here, is there anything else we can add to this? Hey, these have a side that they share, and so it must be congruent to itself. I'll mark it with 3. So I have side, 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 and that is one of our postulates, side, side, side. Okay, good. I think I just have a couple more here. How about this one? Notice again, they're sharing a side, so we can mark that as being congruent to itself. Is this something? Well, I've got a side and then an angle and a side, so side 1, angle, side 2, side 1, angle, side 2. Yeah, that works, side, angle, side. Hopefully you're getting a pretty good feel for this and maybe even figuring this out before I say it. All right, here's our last one. We got a multiple choice this time. The question's being asked in a little bit different way. Okay, so this time they are specifically asking us, we're trying to show angle, angle, side congruence. So this is what we're trying to do, and it's just saying, what of these do I have to prove or to show that would cause me to have angle, angle, side congruence? Well, if you look here, look at this. These have CA and DO that's the side that's congruent. Here's an angle D and angle C. And so again, remember, this has to be in order, kind of working its way around. So we have an angle and a side. Well, what would be missing? We would be missing another angle, and it has to come before this second angle, right? So if you look closely here, what we would have to do is we would have to take this angle and that angle. That's what we would need to have angle, angle, side, because then you have angle, angle, side, angle, angle, side. If you do C and D, we already got that one. A and O, if we did A and O, that would cause it to be angle, side, angle. So it would show that they're congruent, but not what we're looking for. A and G, they just don't match up, and so the only thing left is D. And if you notice, there it is. D is our answer. No bouncing red circle this time, it's an arrow. Wow, pretty cool. I just wanted to put up a quick overview here, just to overview this one more time. And so if you notice here, the side, 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 congruence has all three sides congruent to each other. Side, angle, side looks like this, where you have a side, an angle, and then a side. Angle, side, angle, angle, and then a side, and then an angle, and then, of course, angle, angle, and then a side. Okay, well, that's it. Like I said, not as long as some of the other ones, but hopefully that gives you an idea. We looked at a bunch of examples there, and hopefully that makes some sense to you. So appreciate you being here. This is Mr. Anderson with another edition of Geometry, and I will see you next time. Bye.